So, when you rub a serum into your scalp, you probably just assume it, absorbs and does its thing. But what actually happens at the microscopic level, that dictates whether that bottle is sitting in the cosmetics aisle or, well, locked behind a pharmacy counter.
Yeah, it really comes down to physical boundaries. I mean, we tend to think of the skin as a sponge, right? But it's
Huh.
actually this highly selective biological sieve.
Right, which is exactly why today we're doing a deep dive into this fascinating diagnostic infographic. It's by a researcher named Melvin Sewell from the Cosmic University of Echo Rift Studies, and it maps out something he calls the safety divide in hair science.
And it's such a great visual. We're looking at two specific molecules here. First is a cosmetic active called SH-1, and then there's an investigational drug candidate called PP405.
Our mission today is to figure out why their physical shapes like their actual molecular architecture change absolutely everything about how they are regulated.
To really understand that divide, we have to look at the exact biophysics of how these substances behave, like the very second they hit your scalp.
Okay, let's unpack this. I'm trying to picture it. Is SH1 kind of like a bouncer maintaining order outside a club without ever actually going inside, whereas PP405 is the patron who just pushes past the door and heads straight into the VIP lounge? Like, how does that physically manifest?
That's a really good analogy, actually. What's fascinating here is the mechanism. SH1 is a cosmetic active with purely surface-level activity. It boasts literally zero systemic absorption at all dose levels.
Zero. Like, none at all.
None. It completely maintains epidermal barrier integrity. But in stark contrast, you have PP405, which exhibits what Sewell calls dose-dependent dermal infiltration, meaning it actively penetrates the skin.
Okay, but wait. The infographic says SH1 maintains barrier integrity. I get that it stays on the surface, but how? Is it actively repelled by the skin?
Well, no, it's actually simpler than that. It's just about molecular weight and physical size. Think about the epidermis as a chain-link fence made of lipids and tight cellular junctions. SH1 is engineered to be structurally massive. Trying to get it through the skin is like trying to push a beach ball through a chain-link fence.
Oh, wow. So it physically just cannot cross.
Exactly. It has no choice but to stay entirely on the scalp's surface.
But wait, if SH1 stays completely outside the fence, how does it actually treat the hair or the scalp? Doesn't a product need to penetrate to work?
Not necessarily, no. For cosmetic actives, the target is often just the outermost layer, the keratin of the hair shaft or the dead skin cells on the surface.
Got it.
Yeah, SH1 interacts locally with those surface structures to provide cosmetic benefits without ever slipping past the live barrier below.
Then we have the flip side with PP405.
Here.
The diagram labels its behavior as dose-dependent dermal infiltration, which, it sounds a bit alarming if you don't know what the mechanism is.
Let's break that down. Dermal infiltration just means it successfully crosses that chain-link fence. Its molecular architecture is sleek enough and chemically compatible enough with our skin's lipids to slip right through the microscopic gap.
And the dose-dependent part.
That just means the more you apply, the more deeply it drives into your system.
So what does this all mean for the formulation? Is a cosmetic active like SH1 structurally engineered specifically to fail at crossing the skin barrier, while investigational drugs like PP405 are built expressly to break through?
I wouldn't say fail, but it's deliberately blocked. In pharmacology, penetration is usually the goal. PP405 is an investigational drug candidate. It's designed to reach deeper tissue layers to treat a specific medical condition.
Right.
But that deliberate penetration leads to what Sewell calls a critical threshold breach.
Which brings us to the regulatory side. Once you breach that threshold and enter the bloodstream, you're playing by a completely different rulebook.
Exactly. Because PP405 gets into your systemic circulation, it triggers rigorous clinical testing and heavy regulatory monitoring. It has to prove it's safe not just for your scalp, but for your entire body.
Whereas SH1, because it's essentially a beach ball sitting on the fence, never triggers those systemic alarms. Its non-systemic design keeps it firmly in the realm of cosmetic safety compliance.
Right. Regulators didn't arbitrarily decide one is a cosmetic and one is a drug. The biophysics made the decision for them. The chemistry does the heavy lifting before regulators even see the paperwork.
That's wild.
It is. Engineering a molecule like SH1 to guarantee it cannot sneak past the skin's defenses, to be locally effective but systemically harmless, takes incredible precision.
It completely changes how you look at the products in your bathroom cabinet. This safety divide isn't just bureaucratic red tape. It's a physical reality based on molecular size and shape.
Yeah, it definitely makes you appreciate the invisible architecture inside the bottle.
Next time you pick up a hair serum, you're going to wonder if you're holding a surface-level beach ball or a system-infiltrating key.
For sure.
And it leaves you wondering if cosmetic actives like the SH-1 molecule could be engineered to guarantee zero systemic absorption, what other everyday topical products could be redesigned with this exact non-systemic architecture to completely eliminate absorption risks.